Hey guys, we get to learn some pretty interesting rules today, so let's just dig in. First things first is properties of the product of logarithms. So here's something I know. If I have a logarithm and there's being two things being multiplied together, see how that 5 and 6 are being multiplied together there? Of course we know it's 30, but sometimes it can be helpful to separate those into two separate logarithms. But do you see how they're combined now with this plus sign right there? We can use this to solve equations. If I haven't mentioned this already, you cannot just plug logs into your calculator. I know you're seeing that log button, but it doesn't quite work the way you think it does. So we're going to find out how does this work when you have to do it kind of by hand. You don't know the common log, and tomorrow we'll learn the common log, and then you'll be able to start plugging these into your calculator, but only if it's a common log, and that's the problem. Today these are not common logs. What's a common log? I'll tell you tomorrow. So use, like on number 1, they're going to tell you what one of these logs is. And then they're going to say, do me a favor, approximate that value. Okay? What you want to do, first things first, is remember that log, anytime you have a log where it has the same base as it has this number here, that always equals 1. Okay, you're saying, I have a base 4, how do I make it equal 4? You give it an exponent of 1. So that always works. So really what I have is this log of like a base 4 and then this 2 that I can use. I'm pulling those numbers from here, and I'm going to need a new color, I guess, huh? We'll do gray. I'm using this 2 and this 4 to figure out how can I get, using multiplication, to 32. That's what I'm trying to do. Using a 2 and a 4, how can I multiply and get to 32? And I think I can do 4 times 4, that's 16, and 16 times 2 will give me that 32. So what I'm going to write now, I'm going to erase that stuff. I'm going to rewrite this as log base 4 of 4 times 4 times 2. That's a really inconvenient way of writing the number 32, but it does technically equal the same thing. And also what it allows me to do is recognize that, again, this rule up here will let me separate those. That's going to be handy. It's going to look more complicated for a minute, but I promise we'll get there. Just do the first multiplier plus the log base 4 of the second multiplier plus the log base 4 of the third multiplier. How is that helpful? Because I know that log base 4 of 4 is 1. So I can just rewrite this as a 1. Well, again, 1. And last but not least, this one isn't 1, but they told me over here, what does it equal? 0.5. So, oops, I didn't mean to put a plus. This is super easy math that I can just do in my head. 1 plus 1 plus 0.5 is 2.5. Now, sometimes the numbers aren't quite as nice to work with. Like, for example, that's kind of an ugly decimal. But nonetheless, I can still use it to approximate the 192. The process is the same. I am going to keep going. There will be more examples later. Okay, so the quotient property of a logarithm. If you this time have division, if when we multiplied, we separated out to addition, then when we're dividing, we're going to separate out to subtraction. Kind of goes hand in hand there. So this one, I'm going to use the fact that we have a 3 and this 4, and then I'm remembering that log base 5 of 5 would equal 1. I don't know if that'll be handy this time, but you never know. And so what I see this time is that we've got this fraction. If I rewrite that as log base 5 of 4, I can turn that into subtraction of log base 5 of 3. That was helpful because I can see that log base 5 of 4 is 0.8614. Where did I get that? Right here. Now same thing. Instead of writing log base 5 of 3, I'm going to write 0.6826. Where did I get that? Right here. Now that's maybe not my favorite easy mental math right there, but I can still plug that into my calculator. I forgot a decimal point. Alright, the answer is 0. Whoops. 0.1788. Apparently that's approximately, because these approximately signs, but yeah, close enough. One more rule to show you then. This is the powers property of a logarithm, and what we're going to do here is recognize that if I have a log with a base and it has that exponent, you can pull the exponent out to be a multiplier. How is this helpful? Well, log base 3 of 49. I could do this one by doing log base 3 of 7 times 7, and then separate that out to be the addition here. But the other thing you can do, let me back up here, is turn this into log base 3 of 7 squared. And then what that allows me to do is I can just pull the 2 out. 2 parentheses, log base 3 of 7. Oh, wait a minute. I know what log base 3 of 7 is. They told me right there. So that's just 1.7712 being multiplied by 2. And then that you can either plug into your calculator, or if you've got pretty good mental math here, that's 4, 2, that's going to be a 14, carry the 1. And that'll be my answer. I'm going to pause there, and then I'll come back and do another video on how to use these properties to solve equations.